So our today's topic is cross product, and we are starting today lecture. It is the section 12.4. So this is our topic. So remember one thing, in the last lecture we studied the dot product. So dot product, it is also called the scalar product. So what does it mean? We input two vectors to a system, and in the output we get a number. But now here in this cross product, which is also called a vector product. So what's the main difference here? Suppose that this is our some kind of machinery, and we input here two vectors a and b. It performs some operations on it, and as an output we get a new vector. You can denote this thing with c, or it is denoted by a cross b. So this is what we are going to study today. So suppose that A has the components A1, A2, A3, and B, the vector B, has the components B1, B2, B3. So the cross product of these two vectors, it is defined with the help of the determinant. We call this thing the determinant. I will explain this to you. How do we find this thing? This is the first row. In the first row we write I, J, K. In the second row we write the components of the vector A, A1, A2, A3. And in the third row we write the components of the vector B, B1, B2 and B3. So that's how we have to we define this thing in the following way. But there are few things you need to remember. How do we calculate this thing? How do we find this? How do we expand this thing? So this is the explanation. First of all, suppose that here we have this, let's say we have a 2 by 2 determinant A, B, C and D. How do we expand this thing? This A multiplied with D, this minus comes from the formula, and the B multiplied with C. Okay, so for example, here we have this 2, 1 minus 6, 4. How do we take its determinant? The 2 is multiplied with 4 minus 1 multiplied with minus 6. We get 8 plus 6, which is equal to 14. So this is the answer of this. This is a 2 by 2 determinant. 2 by 2 determinant. And now if we have this 3 by 3, let's say we have A1, A2, A3, B1, B2, B3, C1, C2, C3. How do we expand this thing? Remember, this is called the rows. Okay, I will. So you can imagine this thing. You can say this is our row number 1. Here you have to put the plus sign, minus sign, and then the plus sign. The next thing, how do we expand this thing? This is an important thing to understand, because this is how we will expand this thing. So first you have to put a circle here, write this A1 here, okay, and then what do? We delete this, we cancel this first row and this the first column, and whatever we are left with, we write them here, B2, B3, C2, C3. So this is our this becomes a 2 by 2 determinant. The next thing, you have to put the circle on this A2, and the minus is multiplied with A2, minus A2. The next thing, we again cancel out this first row and this second column, and we are left with this B1 C1, B1 C1 and B3 C3, B3 C3. The next thing is, here we have plus A3, and now we cancel this third column. When we cancel this third column, we get these entries, B1 C1 B2 C2, and that's how you can find the determinant of this thing. This is the formula. This is the formula for finding the determinant. Let us do one example. I will explain this with the help of an example. So suppose that we have this 1 2 minus 1 301 301 minus 5 4 and 2, minus 5 4 and 2, and we want to expand this thing. We want to find the value. What is the final value of this thing? How can you do this thing? We can do this with the first row. It means that here you have to put the plus sign, minus sign, and then the plus sign. Put a circle here, write this one here, and then what do we get here? We will get, it's like we delete this row and this column, and whatever you are left with, write them here as a 2 by 2 determinant. So here we will get 0 4 1 and 2. The next thing is, we put a circle here on this 2 and minus multiplied with 2, right here minus 2. Okay, so the next thing is, we delete this, the first row and the second column, first row and the second column, and whatever the left entries are left, you have to write them in as a 2 by 2 determinant. So here what do we get here? 3 minus 5 1 and 2, and same process you have to do with this minus 1. So plus multiplied with minus 1, and then what do we get? 3 minus 5 0 and 4. Now you can expand this thing. This 0 multiplied with 2, it becomes 0, minus 4, minus 2, and then 6. This minus from the formula, and 1 multiplied with minus 5, it will give you minus 5. Minus 1, this 3 multiplied with 4, it will give you 12, minus, and then 0 multiplied with minus 5, it will give you 0. From the first bracket we get minus 4, minus 2. This minus minus become plus here. 6 plus 5, it becomes 11, minus 12. It is equal to minus 4, minus 22, minus 12. And the final answer, it is equal to minus 38. So that's how you can expand this determinant. Okay, in the next example, we are given two vectors and we need to find their cross product. We need to find their cross product. So here we have this example number 1. The example number 1. So we are given the vectors A, B. Okay. How are we going to do this thing? So A cross B equals, so we make a determinant I, J, K. In the second row we write the components of the vector A 1 3 4, and then comes the components of vector B, 2, 7, minus 5. And now following the same process which we have discussed above, what do we get? You can put a circle around this I and it will give you 3, 7, 4, minus 5, and then minus j, 1, 2, 4, minus 5, plus k, 1, 2, 3, 7. And now you can expand this thing and our final answer will be equal to minus 43i plus 13j plus k. Okay, so as you can see from this thing, the cross product of the two vectors a and b, what is the output? This is our output. This is our output, and this output, it is a new vector. It is a new vector. It is a new vector, so it is different from the dot product. In the dot product, as an output we get a number, but in the cross product we get an output, and this is the reason it is also called the vector product, a vector product. There are few things you need to remember from the previous for example, if we want to find the cross product of a vector with itself. So in this example number 2, we want to show that A cross A equals to 0 for any vector in V3. So it means that when we find the cross product of a vector with itself, the answer is always 0. So this is a theorem, okay, or you can say it is a fact you need to remember. Whenever we take the cross product of a vector with itself, we get 0, and this is a 0 vector. We will use this fact later on in our the next theorem, or it is a result which shows that this new vector A cross B, this is orthogonal to both the vectors A and B, I will show this thing. Maybe you are familiar with this fact from your physics course, but I will explain this here. For example, so suppose that this is our plane, or you can say this is our you can imagine this thing as our ground floor, or the floor where we are sitting, okay, and in this ground floor we have two vectors. A and B. So suppose that this is the vector A and this is the vector B. These two vectors, they lie in this ground floor, in this plane. So what will be A cross B? A cross B, it will be a vector which will be perpendicular to this plane, and here we have this A cross B. So this is how you can imagine this thing. This vector A, it is vector A cross B, it is perpendicular to both the vectors A and B. So this is a fact you need to remember, and you can imagine this thing with the help of the following diagram. Okay, so here we have this diagram. This is called the right hand rule. So here we have the vectors A and B, and the vector A cross B, it is perpendicular to both the vectors A and B. Now there is a second definition of cross product. There is a second definition of cross product. If you remember the definitions of dot product, remember there are two different definitions of dot product. One where we multiply the components of each vector and then take their sum, and the second was defined as we multiply the magnitude of both vectors, and then that product, it is multiplied with the cosine of angle between them. So similarly here we have another definition for A cross B. We have another definition for this cross product A cross B, which is defined in this way. Okay, so this is defined in this way. A cross B, it is equal to the magnitude of A cross B, it is equal to magnitude of A, magnitude of B, sine of theta, sine of theta. So this is the second definition. This is the second definition. Okay, so you can imagine this thing in the following way. I will write this here. I will draw the figure here. So suppose that this is our vector A, and here we have this this is the vector B, and theta is the angle between these two vectors. So A cross B, it is equal to, and we are taking its magnitude, it is equal to the magnitude of the vector A, magnitude of vector B multiplied with sine of theta. Theta is the angle between them. And moreover, if you translate this vector A here, and also you can make this vector B here, so this thing here, it is kind of a rectangle. It is kind of a rectangular object. So when we take this magnitude of A cross B, it will give us the area of this rectangle, the area of this rectangle. The next definition, it is of the following. Suppose that if we have two vectors and we find the cross product of A and B, we find the cross product of A and B, and suppose, and our answer is equal to 0. Our answer is equal to 0. So we find the dot product of the cross product of two vectors A and B, and the answer is equal to 0. Then we say that the vector A is parallel to the vector B, or you can say the angle between them is 0. So this is the vector A, and similarly parallel to B lies the vector B. So these two vectors are parallel to each other. So two vectors are parallel if and only if A cross B equals to 0. This is the same kind of the proposition which we discussed in the case of the dot product. If you remember, when the dot product of the two vectors equals to 0, then we say that those two vectors are perpendicular to each other. That is, the angle between them is 90 degree. So here in this case, when we find that the cross product of two vectors is equal to 0, so it means that the angle between them is 0, theta equals to 0, and we know that sine 0 is 0. That's why our answer is this is the reason our answer is equal to 0. The next thing you need to understand is the geometrical interpretation of the cross product. As I have made this figure, but I will do this one more time here. So what do we call this thing? We call this thing, or you can understand this thing in the following way. We call this geometrical interpretation of the cross product. geometrical interpretation of cross product. So what this theorem says to you, the length of the cross product is equal to the area of the parallelogram, which is determined by these two vectors a and b. Okay, so think about this thing. We have two vectors. This is the vector A and we have another vector B, and theta is the angle between them. Theta is the angle between them. We know from our previous knowledge, how do we find the area of a rectangle? It is equal to the length of the base multiplied with the height between the two parallel sides, and the height here between the two parallel sides, it is absolute value of b multiplied with sine theta. So the length of the cross product of a cross b, it is equal to the area of the parallelogram, the area of the parallelogram. So you can write this thing in the following way. You can write this thing in the following way, that in some questions he will ask you to find the area of the parallelogram. He will ask you to find the area of the parallelogram. We call this thing parallelogram. So it is equal to the absolute value, or you can say the magnitude of this new vector a cross b, which is equal to the absolute value of a, the absolute value of b multiplied with sine of theta, So let us do one example related to this thing. So in this example, what he is asking you, find a vector perpendicular to the plane, passes through the points P, Q and R. You can imagine this thing in the following way. So suppose that this is a plane. You can consider this thing, this is our plane, and in this plane there lies these three vectors P, Q and R. So this is the, let's say this is the point P, let's say this is the point Q, and here we have the point R. What he is asking you, he is asking you find a vector perpendicular to the plane. Okay, we need to find a vector which is perpendicular to this plane. So how you can do this thing? First of all, you can find a vector PQ. Okay, let's say this is the point, this is the vector PQ, and okay, this is the first thing we have to do. We will find the vector PQ, and then another thing, another vector you need to find, which is PR. Okay, and when after finding these two vectors, what you need to do, you have to find the cross product of these two vectors PQ cross PR, and that vector will be perpendicular to this plane. Okay, so this is the vector PQ cross PR, and this is the vector which will be perpendicular to this plane. So that's how you need to solve this problem. Okay, so let's find the vector PQ, and remember from your previous knowledge, it is equal to x2 minus x1, or you can say q minus p. So q minus p, minus 2 minus 1, it will give us minus 3. 5 minus 4, it is 1. Minus 1 minus 6, it is equal to minus 7. And then you need to find this PR. PR is equal to R minus P. R minus P. And when you find this thing, you will get this 0, minus 5, and then uh, PR is equal to 1 minus 1, it is equal to 0, minus 1 minus 5, minus 1 minus 5, it becomes minus 1 minus 4, it becomes minus 5, and 1 minus 6, again it will give you minus 5. So next we find the cross product of these two vectors. Here you can write I, J, K, and then in the second row write the components of the vector PQ, which are minus 3, 1, minus 7, and then write the components of the vector PR, which are 0, minus 5, minus 5, and the next thing we will expand this thing. So this 1 multiplied with minus 5, we get minus 5, and then minus 35, minus j, minus 3 multiplied with minus 5, it will give you 15, minus 7 multiplied with 0, it becomes 0, plus k, minus 3 multiplied with minus 5, again it will give you minus 15 minus 0, and when you simplify this thing, our answer will be equal to minus 40i, minus 40i, minus 15j, minus 15k. So this is a vector perpendicular to to the plane that contains the points P, Q and R. That contains the points P, Q and R. In the next question we have the same points. Okay, in the next question, remember we have the same points P, Q and R. What he says that we need to find the area of the triangle with the vertices P, Q and R. We need to find the area of the triangle with the help of this. So suppose that this is the point P, this is the point Q, R, and what is the question? We need to find the area of the triangle which is formed by these 3 points P, Q and R. So we already have this thing. Okay, we already have this vector from the above question PQ cross PR. So what you need to do, first of all, you need to find the magnitude of this this vector. PQ cross PR, it is equal to under the root minus 40 square plus minus 15 square plus minus 15 square. Okay, so when you simplify this thing, you will get the following. 40 square, it will give you 1600 plus 225 plus 225 plus no plus is it, so this will be equal to under the root square root of, so this will be equal to 250. So this is the area of the parallelogram. This is the area of the parallelogram. When we divide this thing, okay, when we divide this thing with with half, we will get our the area of the triangle. Okay, so what is the area of the triangle? Okay, the area of the triangle, it is equal to 1 by 2 the magnitude of PQ multiplied with PR, which is equal to 1 by 2 under the root 2050. You can leave here. So this is your answer.